All right, I wanted to make sure that we have enough time for today's presentation, so let's go ahead and get started. Thanks to all of you who are joining us today. I'm Caitlin Barnard. I run developer and community marketing here at Kong. I'm also joined by Kevin Chen, who many of you may know as our developer advocate here. So I'd like to welcome you all to March's online meetup. Today, Dennis Kelly, who is our senior cloud engineer here at Kong, is going to be talking about the Terraform module that he created to build Kong clusters in AWS. So with that, I'll hand it over to Dennis. Oh, we can't hear you.
There we go. Thank you, Caitlin. Yes, my name is Dennis Kelly. I'm a senior cloud engineer here at Kong, and I'm also an AWS certified solutions architect professional. So a lot of the stuff I have done with Kong and AWS is also following their best practices in terms of architecture and implementation. Some backstory on this: I originally wrote this module when I was working for Zillow Group. We had implemented Kong as a way to share APIs across all of our brands, and obviously we were following kind of DevOps best practices in doing so and implementing Kong using infrastructure as code, in our case Terraform. I have since left Zillow and have taken over maintenance of the module, and we're using it kind of as our POC demo reference platform to help people quickly get Kong up and running in the cloud with very minimal requirements. And so if you want to go to the next slide, I can talk about some of this. And so you can find the module on Kong Hub, and it really just references the GitHub repository for this. It's all open source and available for anyone to look at and download, modify. And then the link for Terraform. So Terraform is just a single binary that you download, and then it allows you to implement infrastructure as code using a declarative definition. And in our case, I won't get into too much of the details of that, because as we start going through some of the Terraform files, you'll see just how easy it is to describe resources in their HCL, which is HashiCorp's configuration language. And so from here, I can take over screen sharing, and we'll get right into some of the architecture and code. So hopefully you all can see my screen here. I'm referencing some Zillow slides from a talk I did at the Kong Summit in 2018. And just to give of the resources that get created, here you can see in a VPC, we have a Kong cluster A, and you'll notice the Kong instances are in an auto-scaling group, again, an AWS best practice, so that if a Kong node becomes unavailable, that auto-scaling group will automatically replace that unhealthy instance with a healthy one. And then we have two load balancers, one external that we only share via HTTPS and only for the Kong proxy itself. Internally, you can access the Kong proxy through both HTTP and HTTPS, and additionally have access to the enterprise capabilities such as the dev portal and Kong manager. Obviously these sites are old because it was previously called the admin GUI. And then the Kong instances themselves connect to an Aurora PostgreSQL and now newly supported RDS, and optionally an Elastic Cache Redis cluster for things like rate limiting and caching. And so the other thing too is, with all of these different connections, all the security groups are a minimal access only, and so it's default deny, and we only allow the actual connections that we need from the hosts that actually need it. And so here I have up on the left-hand side of the screen the actual GitHub Kong Terraform module for AWS. Again, it's all open source, and uh, you know, you star it, which would be awesome. And then I do accept issues and pull requests, and I try to be pretty responsive with those. We're always trying to add new features and capabilities. I think some of the things in the pipeline right now are support for AWS's newer load balancer, the network-based load balancer, and adding additional configuration for instances. And so if we scroll down, the README here tries to explain, much of what is going on in the diagram in terms of what is provisioned. And the Kong nodes themselves are based on minimal Ubuntu, and this is a very stripped down, lean, and secure version of Ubuntu specific to the cloud. So it's highly performant and very secure. And we only add a minimal set of dependencies and debugging tools. We also add Deck, which is a declarative configuration management tool written by one of our other cloud engineers, so that you can, again, apply DevOps principles to not only provisioning Kong clusters, but also configuring Kong itself. And then we do set up some other systemic things to make sure that the nodes are healthy and don't need intervention in terms of like log rotation and stuff like that. And so the prerequisites are pretty minimal. You need an AWS VPC, and there are actually other Terraform modules in the Terraform what they call their hub. And so you can easily set up a new VPC using that. And then we have you tag your public and private subnets with a tier tag. And so in your VPC setup, you would go to your subnets, and you could do this with the Terraform version of the VPC module. Just add this tag to denote whether it's private or public. And we do that to determine where Kong instances get provisioned, where the external load balancer gets provisioned. You also need a database subnet group, and that's similar in terms of the private and public notation, but this would be just in RDS. You would define what subnets would be available for databases. And the same thing with the cache subnet group. This is optional, as Redis is optional as well. You also need an SSH key for logging into your Kong nodes, and then an SSL managed certificate for the HTTPS load balancer. And then beyond that, these are a list of all the variables that you can tweak in terms of how you want to set up your Kong cluster. But in the process as well, we've provided, sane defaults for almost all of these, to where there's just a very minimal set that you would actually have to define in order to set up a Kong cluster. But they're here for reference so that you get an idea of what you can actually tweak and do. And so I provide of how you would instantiate the Kong module to build a Kong cluster. And so the only file you would need is a main.tf, and we're looking at Terraform here. And so you need to define a provider. And so this needs to be AWS. And it's going to then rely on the AWS CLI configuration. And so we're telling it we want to build this Kong cluster in the region of US West 2. And we want to use the AWS CLL profile called dev. And that will have your API key and your secret key in order to access Amazon's API for provisioning services. And then we actually call the Kong module. And so we're calling it from GitHub here, and we're referencing a specific version. And this is something that I highly recommend as we may introduce breaking changes between releases. And so this will hold you set steady at a release so that you can then, if you want to upgrade to a new release to get new enhancements or features, you can take a look at that and make sure there's no breaking changes that would happen in your environment before doing so. And so here are the minimal set of variables that you would need to define. And again, it comes from the prerequisites. And so you have your VPC name, and here I just called it my VPC in the demo. And then the environment is just dev, your EC2 key for SSHing in, and then the certificates you want to use for SSL. And even though you may not be using the enterprise version, you still just need to define those certs to something, even though they won't be used. I am working on making those optional as well, to where you won't need to do that if you're just installing Kong Community Edition. And we then also supply some tags down here to further denote the resources that are going to be defined. And there are also a set of default tags that will be applied so that you can then later look at cost analysis of what you're spending on Kong. And then to actually create those resources, it's pretty simple. You're just going to run terraform init. And what that does is actually downloads a local copy of the module to your system and sets up the environment. And then Terraform Plan will then take a look at what's in your AWS environment in terms of the resources it's going to use, like subnets and the subnet groups for databases and caching. And then Terraform Apply, that plan will actually provision what needs to be provisioned. And so Terraform is stateful in that sense. And so say you're provisioning something and then Terraform errors out or times out, it can then refresh that state with a new plan and only provision the changes that need to be done. And likewise, if you start out with a very small minimal configuration and then want to tweak that later on, you can then just apply those specific changes without having to destroy and rebuild everything from scratch. And so one thing I didn't mention is that the module supports both the community edition and enterprise. And so if you are running the enterprise edition and say don't want to store your enterprise license key or bin tray authentication in a Git repo, you can, while the services are being provisioned, you can go into the systems manager parameter store and update the values in these locations. And so the parameter store is a secure key value service in AWS. And so at rest, your license and bin tray auth are going to be encrypted. And we use an IAM instance profile, so the Kong nodes are given permission to read those values, not even write them, but just read. And so once everything is provisioned, you can then use your EC2 key to SSH into one of the instances and then begin setting up APIs in Kong. And so that's just like a brief overview of it. We can go into some of the details now and look at more Terraform to give you some confidence moving forward with it. And so here's the EC2 Terraform to provision the Kong instances themselves. Wow, internet's slow for me today. And so at the top, you see we have a launch configuration and then the auto scaling group for Kong. And this is going to define the instance type and the image ID that we use to provision Kong, and also the security groups. And then the auto scaling group defines kind of the parameters around how many Kong instances we're going to run. and how we're going to manage the health of those, and then what load balancers we're going to associate with that. And here you can see we're also adding tags that get propagated at launch time. And then our cloud init configuration defines how we configure the Kong instances themselves. And so here we're passing in a shell script template and a cloud init configuration at the boot up of one of the nodes. And so, and then we include a bunch of variables that can dynamically configure the actual host. And so taking a look at the cloud init config, it's again, very minimal. We create a user and group for Kong to actually run Kong itself. We enable or we install recommends set to false. So again, that we're not adding additional packages that we don't really need. And then a minimal set of dependencies for both Kong and debugging tools that we can use. The cloud init.sh is actually we're using the AWS CLI to get parameters from that parameter store for all those secure values. So again, nothing gets written into our module or into your instance of the module in clear text. And so we enable auto updates to make sure that the hosts are secure. We install deck. We then install Kong, and we can do that based on whether the license is configured or set to something other than the default. And then we configure the database and set up the Kong configuration file. And again, it's dynamically pulling these values for you. And then we initialize Kong to set it up to run. And then also it's log rotation. And we use a program called Run It, or SV, to start Kong under supervision. So this is kind of something not from the default, but as a good practice from an enterprise perspective, in that you have a supervisor process making sure that Kong is running all the time. And if it's not, it can be restarted. And we actually then do some we get Kong up and running, and we do some initial configuration of it. And we actually use Kong to provide Kong's health checks so that it's kind of like a deep ping, making sure that your service is running properly. So we're going to check to see if we have a status endpoint that we've created in Kong. And if not, we'll actually create your first API endpoint. And so you have a service and a route associated with that. And what we're doing here is exposing the admin API status via Kong on the proxy port. And then we restrict that endpoint to the VPC CIDR block so that the load balancers themselves can check the health of the Kong nodes without requiring authentication, because in enterprise mode, that admin API is going to be protected by RBAC, and in the community edition, that we're not going to even expose the admin API externally because there is no security there. So you would need to access it from local hosts. And so again, we're implementing some best security practices, but also leveraging Kong to expose the Kong health checks. And then at the end of it, we restart Kong, and then your nodes are up and running successfully. And so here's some of the data that we pull from your, and that's why we need a name for the VPC, because we're just going to dynamically look that up. We're going to dynamically look up your public and private subnet IDs based on that subnet tag. and then a default security group that you want to associate with your Kong nodes. And this could be like, hey, I want to allow SSH from these specific Bastion hosts. And then on top of that, we do create a Kong security group that, allows access to the Kong specific ports. So this would be basically for, any additional things that you would want to do with the nodes outside of providing Kong, like say you want some remote monitoring or alerting tool to be able to check stuff, you could add that to your default security group. And then the IAM instance stuff is really cool and important. And, this is where we, again, provide Kong access to those parameter store values that have been secured. And so, here we're allowing it to get parameters from the parameter store and decrypt it using the key that we set up for those. And then we have an IAM role policy that gets associated with each node so that, again, it doesn't require a username and password embedded somewhere in order to do that. It's leveraging AWS's instance role profiles with the EC2 metadata to get a temporary token to access those resources securely. And then outside of that, you can, take a look at how we set up Amazon's database. And now it is optional whether you use just standard RDS or the multi-master Aurora. But yeah, we don't need to go into too much more detail on that piece. I will pull up an example here. And so here I have a test directory that I've created. I really only need the main.tf, and I've actually run Terraform in here before. It will create this Terraform state and a backup state for you. And so here I'm going to run this against version 3.4, the latest version. I have my AWS provider set up. We're going to, create resources in US West 1, and I'm using my Kong Cloud access keys to provision. And so you can see up here, I'll scroll back, going back to the README, do the Terraform init. And so it's initializing the modules, downloading it from GitHub, and then initializing the backend for the storage state, which is in this case local. I actually highly recommend that you use an S3 bucket that is encrypted to store your state, because there could be sensitive information that gets stored in there, and you don't want that in your GitHub repo. That and S3 state is far more shareable from a enterprise multi-user environment, and it's going to be backed up to avoid problems. And then once it's initialized, you can see here that it's saying you should probably pin your versions for the different providers that we're using. I do recommend doing that, and you can find information from Terraform's website on exactly how to do that over here in your main.tf, because there could be changes within the AWS provider or random provider that could potentially break your setup in the future. And so while we're pinning a version of the Kong module itself, it's also good to pin those provider versions. And so with everything initialized, we can run Terraform plan. And so it's pulling that data from your VPC and the SSL certificates, subnets that we talked about. And then it's just going to show you all the things it's going to create. And so you can read through all of this to get an idea of what Terraform is actually going to do. And note that Terraform's only going to manage what is configured in the Kong module. You can have other AWS resources that will not be touched by this Terraform module. And so, there's a lot of stuff getting created for you that's being automated. And so here it wants to create 57 resources. And if I do a Terraform apply, it would actually go through and create all of those. And I'm going to just get it started to let you know how that works. But we'll say yes, and like here it's off going and doing its thing. It takes about 10 minutes to provision all the resources because the database itself, RDS, takes a while to create that database engine and configure it and get it up and running. And so it's really just a time now for you to go get coffee and then come back and you'll have a Kong cluster up and running. So here you can, hopefully see the power in all of this. You have a very small file and one binary, and you can have a Kong cluster in about 10 minutes. And so, yeah, I'm happy to answer any questions at this point.
Awesome. Thanks, Dennis, for the great presentation. If anybody has any questions, feel free to either drop them in chat or you are able to unmute yourself and ask live as well.
You can't tell me my presentation was so powerful that I answered every possible question. Yeah, and so while we have created this to be, kind of, hey, I want to demo Kong or POC Kong in the cloud, yeah, we want to be able to help you do that really quickly. We do have people starting to use this for their production environments because, again, we're, leveraging a lot of the DevOps practices, security practices where, it kind of makes sense. And so we're trying to now extend the module to support some more customized configurations so that, you're not just getting a reference platform. You can then say, install some external monitoring tooling that you might use specific to your environment. Basically, you just again provide same defaults to get this up and running for a POC, but then offer power and flexibility for you to extend this easily. Oh, looks like we maybe have a question.
No, sorry, that was me. I'm
posting
dropping all the links in the chat.
No, thank you. Appreciate that.
That is so excited.
I know. Someone wants to talk to me because I do live way out in the mountains. I'm in a town of 200 people. And so, these online meetups are a great opportunity for me to socialize. And I do want to apologize for my raspy voice. I am getting over basically the plague, coronavirus, or whatever you want. I actually don't have that, but yeah, so sorry for the the throat problems. And so, yeah, the other nice thing about this is, Terraform has the ability to completely manage everything. So while I'm spinning a bunch of resources up and now costing Kong a bunch of money, before we actually cost Kong money, I can destroy it, just do the Terraform destroy, and it will, basically take your AWS account back to where it was before you ran the Kong module. But yeah, other than that, I can, it's going to take about 7 more minutes. But after that, you do have a Kong cluster up and running, ready for traffic. And so I'm going to stop sharing my screen and hand it back over to Caitlin. And yeah, just wanted to thank everyone for their time.
Yeah, thank you so much, Dennis. And thanks for everyone who's joining us. If you do have any questions after the fact, feel free to email us or hit us up on Kong Nation as well. The recording of this will also be live later today. So if you want to take another look and maybe you have questions then, let us know. So our next call will be on April 14th. And have a great day, everyone.